students, good morning. Welcome to Maths online class. Now today's class we do revision. Okay, since you have exam next, for that this is a revision class. And when I do revision of some problems, same type of problems you have to take and you have to practice that. Okay, so then only revision is effective. And I taken some problems from number systems chapter. Find 6 rational numbers between 3 and 4. How to write 6 rational numbers between 3 and 4? Actually there are infinitely many rational numbers are there between given two numbers. Okay, now you are given 3 and 4. Between any two numbers there are infinitely many rational numbers are there. Now how to find rational numbers between 3 and 4? And you are asked 6 rational numbers to find. Okay, so now 3 and 4, for that if they ask 6 rational numbers to write, you take one more than that, that is 7. Okay, 6 plus 1 is what? That is 7. You have to multiply 7 and you have to divide by 7 to 3, and also for 4 into 7 dividing by 7. So that gives what? 3 into 7, that is 21, 21 by 7, and here 4 into 7, that is 28 dividing by 7. Okay, 28 by 7 is equivalent to 4. If you simplify 28 by 7, you will get 4, and if you simplify 21 and 7, you will get 3. So 3 equivalent we taken here, and 4 equivalent number 28 by 7 we taken. Now easily you can write 6 rational numbers, 1, 2, 3, 4, 5, 6. So in all these 6 rational numbers, denominator you have to write same. Okay, denominator is what? First and last you have denominator 7, right? So for each rational number you have to write a denominator 7. After that numerator you have to increase by 1. After 21, what is the next natural number? 22. After 22, next 23, next 24, next 25, next 26, next 27, and 28 by 7, that is what? That is 4, and here 21 by 7, that is 3. Like this you have to find 6 rational numbers. Okay, if they ask 7 rational numbers to find, then you have to multiply by 1 more than that, that is 8. You have to multiply and you have to divide by 8. Okay, so like that you have to find. Okay, I will not do more than one problem, only one problem under that. Next, suppose you are asked like this, 5 rational numbers between 3 by 5 and 4 by 5. Now here you are given in a fraction form. Okay, so now also same type. Okay, now here you are asked 5 rational numbers. So what you have to do for the given numbers 3 by 5 and 4 by 5, what you have to multiply to both the numerator and the denominator, you have to multiply by the same number. Which number you have to multiply? Which number? To see that you have to look at this 5. Okay, we are asked 5 rational numbers to write. 5 plus 1 is what? 6. Okay, one more than this you have to take, that is 6. 6 you have to multiply to both numerator and denominator. Here also multiply both the numerator and denominator by 6. We are given 3 by 5 and 4 by 5. We multiplied by 6. Why? Because we are asked 5 rational numbers. One more than that you have to multiply to both the numerator and denominator of given two rational numbers. Okay, now 3 into 6 is what? That is 18. 5 into 6 that is 30. Okay, and here 4 into 6 that is 24 dividing by 5 into 6 that is 30. Okay, now these two rational numbers are equivalent to given two rational numbers. If you simplify, if you cancel these both numbers by 6, you will get 3 by 5. Okay, so this number is equal to 3 by 5. This number is equivalent to 4 by 5. Now we write 5 rational numbers, 1, 2, 3, 4, 5. Okay, for all these 5 rational numbers, denominator is the same, 30, 30, 30, 30, 30. Okay, denominator you have to write the same, numerator you have to increase by 1. Okay, look at previous numerator, increase by 1, 19, next numerator is 20, next is 21, next is 22, next is 23 and 24 is here. Okay. So these are the 5 rational numbers in between given to rational numbers. Actually you can find infinitely many rational numbers in between given to rational numbers, but here asked limited number of rational numbers. Okay. Next, types of decimal expansions of rational numbers. You know that rational numbers have 2 types of decimal expansions, that are terminating decimal expansion and non-terminating recurring decimal expansion. When you get a terminating decimal expansion, if a remainder is a 0, see, if a remainder while dividing numerator by denominator, if you get a remainder 0, then that type of decimal expansion is called terminating decimal expansion. Okay. Sometimes you will not get a remainder 0, but that remainder will start to repeat after certain stage. Okay. So then you have which type of decimal expansion? Then you have non-terminating recurring decimal expansion. Okay. Under that you will be given some problems. Okay. You are asked like these questions. Write the following in a decimal form. You have to write these fractions in a decimal form, and you have to say what kind of decimal expansions that has. Okay, it has. That you have to find. Okay, so this is both numbers are rational numbers. So either they have terminating or decimal expansion or non-terminating recurring decimal expansion. How to identify? To identify that you have to divide numerator by denominator. So now first 36 by 100. 36 you have to write inside and 100 you have to write outside. 100 doesn't divide 36. So take a 0 and put a pointer. Okay, because there are no digits. And after that take a 0 with this 36. Now 360. 360 how many times? 100 divides 360 3 times. Okay, 3 times 300. And what is the remainder? Remainder is 60. Okay, take a 0 with this 60. Now 600 how many times? 100 6 times 600. So here we get a remainder 0. So here division stops because we get a remainder 0. Here division ends. Okay, division stops at this stage. So here which decimal expansion we got? 0.36. Okay, so that is the decimal expansion of 36 by 100, 0.36. And which type of decimal expansion this is, that you have to write. Okay, without missing you have to write. This is a terminating decimal expansion. Okay. Don't miss this to write. After finding the decimal expansion, this you have to write. Okay, this is which type of decimal expansion, that you have to write below that decimal expansion. Okay, now 1 by 11. 1 by 11. Divide 1 by 11. Write 1 inside and 11 outside. 11 doesn't divide 1, right? So write 0 in the quotient place and take a pointer with that, because there are no digits here, and take a 0 with this 1. Now this is 10. Now 10 also not divisible by 11, so take a 0. Okay, don't miss this 0, be careful here. 10 also not divisible by 11, so you have to write 0, don't miss this 0. Okay, so here you take one more 0. Now 100, how many times we can take we can take 9 times. 11 into 9, that is 99, and 100 minus 99, that is what? That is 1. Now we can see that here that 1 that is repeated, right? Same one, with the same one we started, same one is repeating here. So now 11 doesn't divide 1, right? So you have to take a what? 0 here, and if you take one more 0, then also that is not divisible. Sorry, here remainder we got 1, right? And this 1 is not divisible by 11, and you take a 0. Now after taking 0 also, that is not divisible by 11, right? So you have to take a 0 here in a quotient place. Now you take one more 0 with this. Now this is 100. So 11 how many times? 11 9 times 99, and remainder again we got 1. Okay, and if you take 1 0 with 1, we get 10. 10 is not divisible by 11, so put a 0 in a quotient place and take one more 0 with the 10. Now 100, 11 how many times? 9 times. So like this that division continues. Why division continues? Because same remainder is repeating again and again. Okay, after certain step remainder is repeating here in a division. So then now we get which type of decimal expansion? We get which type? That is a non-terminating. Non-terminating means that never ends. Non-terminating recurring. Recurring means repeating in the same type 090909 like that repeating. Okay, so here we have which type of decimal expansion? Non-terminating, that etc symbol that indicates a non-terminating. Recurring you can see here. Okay, repeating 0909, they are repeating they. So 1 by 11 that is equal to 0.09, and here you see 0909 like that repeating, and we write that in short as a 09 bar. Okay, this bar under the bar which digits are there, that digits are repeating. Okay, this bar indicates that under the bar which digits are there that are repeating. Okay, you can write in this way 0.9 whole bar, or you can write in a detailed way like this 0.090909 etc. Okay, like this you can write. And this is which type of? This is non-terminating. Non-terminating recurring decimal expansion. So for a rational number you have either a terminating decimal expansion or non-terminating recurring decimal expansion. And suppose you have a decimal number which is in this type, that is a non-terminating, means a etc symbol will be there in that decimal expansion. And non-recurring, non-recurring means digits are repeating but not in the same order. If digits are repeating but not in the same order, then that type of decimal expansion is non-terminating, non-recurring. For example, this one 0.09001, sorry, 0.010010001 etc. like this. Here you can see 0 and 1 now they are repeating but not in the same order. Here 0 is repeated only once, here 2 times, here 3 times like that. Okay, so here etc symbol is there, means that is non-terminating. And non-recurring, non-recurring means repeating but not in the same order. Okay, so if you have such type of a decimal expansion, that is a non-terminating, non-recurring decimal expansion, and that is only for irrational numbers. Okay, next classify the following numbers as a rational or a irrational numbers. You will be given some numbers, you have to identify them as a rational or irrational numbers. Okay, suppose you are given numbers in this type of square root form, then you have to keep this in your mind. Okay, suppose inside the square root perfect square number is there, perfect square number is there, then that is what? That is a rational number always. Okay, for example, suppose you have like the square root of, which are the perfect square numbers? 1, square root of 4, square root of 9, square root of 16, square root of 25, square root of 36 like that. If inside the square root of perfect square numbers are there, then that number is always rational. Okay, if inside the square root non-perfect square numbers comes, then that will be always a irrational number. Okay, so like that you have to identify rational or a irrational number. You have to keep these important things in your mind. Okay, now here you see square root numbers. You have first 4 numbers which are in square root form. Square root of 23, 23 is not a perfect square number, so square root of 23, that is which type number? That is an irrational number. Okay, now here square root of 25, 25 is a perfect square number. So which type of this number is? This is a rational number, because the square root of 25 means that is a 5. Okay, square root of 9, perfect square number 9. Okay, so square root of 9 is which type of number? That is a rational number. Okay, and a square root of 4, and this 4 is what? That is perfect square number. So this is also rational number. Okay, if inside the inside the square root of perfect square number there, then that are rational numbers. If inside the square root of non-perfect square numbers comes, that are irrational numbers. Okay, and suppose you have decimal numbers like this, then how to identify whether they are a rational or irrational numbers? If etc symbol like this, etc symbol is not there, then directly you write that is a rational number, because etc symbol not there means that implies that is a terminating decimal expansion. Okay, so here etc symbol after decimal point, etc symbol not there means you have to write that as a rational number. Why? Because that type is a what? Terminating decimal expansion. And if a bar is there, if after the decimal point the bar is there, then that is also rational number. Okay, so here after the decimal point, if bar is there, and if after the decimal point etc symbol is not there, then that are rational numbers. Okay, and this number 9.53 bar we can write in this way also, 9.5353 etc. Okay, under the bar which digits are there, that are repeating in the same type, 5353 53 like that. Okay, here you can see etc symbol, and if etc symbol is there after the decimal point, then how to identify that as a rational or irrational? You have to see digits how they are repeating, whether they are repeating in the same order, same type. If they are repeating in the same type, that is a rational. Okay, here etc symbol is there, and you can see after the decimal point digits are repeating in the same type. So this is what? This is a rational number. Okay, if digits are repeating in the same type after the decimal point, that is a rational number. And here 9.53 553 5553 etc. Here etc symbol is there, and you see how digits are repeating. Digits are repeating here, but they are not repeating in the same type, not repeating in the same order. So if you have like that decimal expansion, that is always a irrational number. Okay, so here irrational number for decimal form numbers, how to identify? Suppose etc symbol is not there after the decimal point, then that will be a rational number. Suppose etc symbol is there, then how to differentiate a rational or irrational? You have to see how digits are repeating. If digits are repeating in the same order, same type, then that is a rational. If digits are not repeating in the same type, that is a irrational number. Okay, like that you have to differentiate rational and irrational numbers. Thank you. Next you have like these problems, that is you will be given some decimal numbers, you have to express that in a rational form, p by q form, where p and q are integers and q not equal to 0, denominator not equal to 0, means these decimal numbers you have to write in a rational form. Okay, p by q form, where denominator should be not equal to 0. In this type you have to write. Okay, so now first one 2.5. Suppose you are given 2.5, how you will write that in a rational form? Here you have to see after the decimal point how many digits are there? Only one digit, right? So if only one digit is there, you have to multiply by 10. If after the decimal point two digits are there, then you have to multiply by 100. You have to multiply and you have to divide by 100. Okay, and if after the decimal point, if 3 digits are there, then you have to multiply by 1000 for both numerator and denominator. Okay, so here now after the decimal point you have only one digit, so you have to multiply and divide by 10. Okay, so then what you will get 25 into 10 that is 250, right? Without decimal point this is 25 into 10, 250 dividing by 10, and there is a decimal point after one digit from the right side. Okay, so put the decimal point after one digit from the right side. So it is what 25 dividing by 10, and if further you can simplify, you have to simplify that further. Okay, here both the numbers are divisible by 5, so take a 5 to divide, 5 times and 5 2 times. So this is what, this is 5 dividing by 2. Okay, so P by Q form of this decimal number 2.5 is what 5 by 2. Okay, next this one 2.5 bar. You have to take this as x equal to 2.5 bar. 5 bar means under the bar how many digits are there, that you have to see. Only one digit. If only one digit is there, you have to multiply x by 10. Okay, on both sides of x you have to multiply by 10, but before that you have to write x in a detailed way. Okay, this is a short way of writing. You have to write this in a detailed way. Detailed way means bar is there means you have to repeat that digit under the bar some number of times. Okay, I will repeat 3 times. Under the bar you have 5, so I will repeat 5 3 times, and you have to put etc symbol. Okay, etc symbol means like that 5 is repeating, and you take that as equation 1. And next you have to look at like this. Under the bar how many digits are there? Only one digit. If only one digit is there, you have to multiply by 10. Okay, number 1 followed by 10. Okay, now after multiplying by 10, what we get? 10 into x, left side 10x, and here after multiplying by 10, what you will get? Always you keep in mind that for any decimal number, if you multiply by 10, for example, this is a rough explanation. Okay, suppose you have 3.56 3 into 10, you know how to multiply, but without a multiplication you can write a direct answer. If you multiply by 10,000 like that, if you multiply by 10, after multiplying this decimal point will be shifted to one digit to the right side. So your answer will be 35.63. That you can check. Okay, later you check. And if you multiply by 100, so then decimal point will be shifted to 2 digits to the right side. Okay, how many zeros are there in 100? That many digits to the right side you have to shift that decimal point. Okay, so answer will be 356.3. Okay, if you multiply by 1000, then this decimal point will be shifted to how many digits? How many zeros are there? That many digits. To that many digits you have to shift decimal point. So decimal point will be where? It will be 3563.0. Answer will be like this. So that thing you have to keep in mind. Now we are multiplying by 10 to this decimal number. So this decimal point will be shifted to one digit to the right side. So your answer will be 25 point. Remaining are all 5 5s. Okay, and you take this as a 2. Now you have to subtract equation 1 from 2. Okay, 2 minus 1. Write 2 first. 10x is equal to 25.555 etc. Okay, and below that write this equation 1, x equal to 2.55. While writing this one, be careful. Under the decimal point you should write a decimal point, and here you have 55 etc. and before the decimal point only one digit, that you have to write below this 5. Okay, not below 2. Okay, be careful. And while subtracting you will change second row numbers sign. 10x minus 1x, nothing is there means number is 1 there. Okay, 10x minus 1x, that is 9x equal to, here after the decimal point all are zeros after subtracting. Okay, so 5 minus 5, 5 minus 5 all are zeros, and here 5 minus 2, that is 3, and 2 minus nothing is 2. Okay, So 9x is equal to 23.00 means after the decimal point if 0 zeros are there that you can leave. Okay. So 23 x is equal to what? X is equal to 23 by 9 like this. Okay. And next is 2.53 bar. Okay. You have to see the difference between this one and this one. Here under the bar only one digit is there, that is 3. Only 3 is repeating. Okay. So you take x as the detailed form of this. Okay. That is 2.53. Under the bar which digit is there, only that is repeating, only 3 is repeating. Okay. So repeat that some number of times. I repeated 3 times. And you take this as a equation 1. You have to take this number as x. Okay, in detailed way you have to write, not in short way, and take that as equation 1. Now under the bar how many digits are there? Here you should not see after the decimal point how many digits are there. If bar is there, under the bar how many digits are there, that you have to see. Under the bar if only one digit is there, you have to multiply by 10 on both sides for equation 1. If under the bar 2 digits are there, then you have to multiply by 100 like that. Okay. So now we have only one digit under the bar, so you have to multiply by 10. So now 10 into x is what? That is 10x, and here we are multiplying 10 to this decimal number. So decimal point will be shifted to one digit to the right side. So after multiplying by 10, your answer will be 25.333 etc. And you take this as a equation 2. Okay. Now you have to do this operation, equation 2 minus equation 1. Write equation 2 first. 10x is equal to 25.333 etc. Next equation 1, below that carefully you have to write. Okay, x is equal to 2.533 etc. Okay, under the decimal point you have to write a decimal point, and after decimal point 533 carefully you have to write, and before the decimal point only one digit that you have to write below this 5, not below 2. Okay, and subtract 10x minus 1x, this is 1x, 10x minus 1x is 9x, and here 3 minus 3 that is 0, 3 minus 3 0, and 3 minus 5 we can't, so take 1 from this, and 13 minus 5, 13 minus 5 is 8, and how much left here? 4 minus 2 that is 2, and here 2 left. So x is equal to 9x is equal to this much we got. 9x is equal to 22.8. These zeros you can leave. Okay. And from this, what is x is equal to? X is equal to 22.8 into 9, another side as dividing by 9. But here we have to express in a p by q form where both p and q must be integers. But here we have decimal number in numerator. So how to make that as an integer? To make a decimal number to integer, you have to multiply by 10 now. Why? Because after the decimal point you have only one digit. If after the decimal point only one digit is there, to make it a integer you have to multiply by 10. If after the decimal point 2 digits are there, to make that as a integer you have to multiply by 100 like that. Okay. Now only one digit is there after the decimal point, so you multiply both numerator and denominator by 10. Okay. So that x is equal to 22.8 dividing by 9. Actually we got like this. In next step you have to write into 10 for both numerator and denominator. Okay. So then you know that decimal point will be shifted to one digit to the right side after multiplying by 10. So your answer will be 228 dividing by 9 into 10, that is 90. Okay. And both are even numbers, you can cancel by 2. 2 4 times 8, 1 left, 2 5 times 10, and here 2 once 2, how many times? 2 4 times, and we can't divide this further, so answer is what? 114 dividing by 45. And next one is this one, 2.53 whole bar. You have to take that as x, okay, but in a detailed way you have to write x is equal to 2.53, under the bar 5 and 3 are there. So you have to repeat that some number of times. I will repeat 3 times. Okay. etc. And take this as equation 1. Now under the bar you have 2 digits, so you have to multiply by 100 on both sides. So then you will get 100x is equal to, since we are multiplying by 100, you have to shift this decimal point 2 digits to the right side. So your answer after multiplying by 100 will be 253.5353 etc. Okay, and take this as equation 2. Now do this operation, equation 2 minus equation 1, subtract 1 from 2. So then write equation 2 first, 100x is equal to 253.5353 etc. and equation 1 below that, x is equal to 2.5353 etc. But while writing that, be careful, below the decimal point you have to write a decimal point, and here 2, and after decimal point 53 etc. Okay, and subtract now 100x minus just x means that is 1x, 100x minus 1x is 99x equal to, here after the decimal point you will get all zeros. Okay, 5 minus 5, 3 minus 3, all are zeros etc. and 3 minus 2 that is 1, and here 5, and here 2. Okay, so 99x is equal to how much? 251.00 you can leave. Okay, so it is 251. So x is equal to 251 into 99, another side as by 99. Okay, so this is what? This is P by Q form of last fourth one. Okay, like this you have to express given decimal number in a P by Q form. Okay, thank you.